So today's repair nightmare here at Michigan Pinball Repair, VFWpinball.com, is the Barracora. Now the Barracora is a fairly rare and somewhat desirable game. And what happened is this playfield appeared on Facebook Marketplace for $75. Now it wasn't in this condition, but there it was, $75, and I thought I should buy that because I have a Barracora back glass, a spare one, and why not try and make a Barracora? If I got a playfield and a back glass, all I need is a cabinet, right? Well, I talked to my good friend Mike Wiley, and he gave me this Tri-Zone cabinet. Now, Tri-Zone is a Williams System6, and Barracora is a Williams System7. So you may wonder what's the difference, and one of the main differences is the score displays. On System7, you have 7-digit displays, where System6, like this display here, you have 6-digit displays. So originally I thought, well, why don't I just lop off the last digit here, and instead of 2.5 million for the high score, it'll say 250,000, and we'll lose this digit here because it's always a 0. So that was my original thought on the conversion process. And I actually was fairly successful at making that happen. But the problem is that I didn't have enough 6-digit score displays. So I ended up buying this Rotten Dog score display system, 7 digits, and just convert the System6 to a System7 display system, which wasn't really that difficult. It required some pinning of the pins right here, and then the two outside ones here and here had to be added. Those are just for the commas. So these score displays, they have lit up commas, and System6 displays don't have that. So we'll get to how that got incorporated, but first let's talk about what's going on back here. So System7 games have a different power supply. This is a System6 power supply, but you can still use that. That'll work. Give me power. Soundboard was different than Tri-Zone. This is a System7 soundboard, and we'll talk about that in a second. And then, of course, you need a System7 MPU and driver board. I chose to go with the Weebly system, Andrew's Weebly. If you go to Weebly, type into Google Weebly Pinball, and his system will come up. This is a really nice all-in-one combo board where you can set the dip switches to the game that you want. Really, really nice board, and it's $100 cheaper than any other reproduction board out there. And he does a great job. Like, he has some surface mount stuff, but notice how he puts through hole in the board. That way, if you burn up a surface mount device, like here, check this out. If you say you burn that chip up, you could get the surface mount off and then put a plated through socket like this one has into the holes that he's provided. Really nice, serviceable board, all in one. So other than the score display hanky-panky on this connector and having to make all the ribbon cables, because the original harness was this one here, which we had to abandon to get the 7 digits to work. So I had to mount this board. This comes in the Rotten Dog package. And of course, the Rotten Dog package does not include ribbon cables, so I made my own ribbon cables. Then mounted the displays. You can use the original top holes. These are the 6-digit bottom holes, which I just don't use. Yeah, the displays aren't quite as bolted in place, but believe me, they're fine. And then this one, you actually do have to reposition. You can see the old holes from the larger 6-digit display that used to be there. Looked like this. See, it had those larger holes. So this one was a bit tricky to get mounted in the back glass. But the score display parts were fine, other than the ball and credit display. I want numbers. You may be wondering how I rewired this or how I knew how to rewire it. So basically what I did is I made myself a little map here. And Here by my thumb is the master display pin numbers, which are here, and the dot is 1, and it goes up to 18. And then what I did is I documented the System7 wire colors versus the System6. Now the wire colors are identical. That is, where these connectors start is here on the CPU board at J7 and J6. And then they just go over to here to this connector. And this connector is used on both the System6 and System7s. So all I did is, it was originally through this slot. I just pulled it out there, and then I removed all the wires from here. And the way I did that is I used my Molex connector pin removal tools. Now this red one here, I used to remove pins from this connector, the round pins. So we're not using that here. But this one is the one that I actually use to remove the pins from this connector. So what you do is this guy slides down in here. And then once you get that thing down all the way, you can pull all the wires, you know, each pin out of this connector. And I pulled them all out because if you look at our map again, you can see there is no common wires. When they went from 6-digit displays to 7-digit displays, they completely changed the wire orientation. So again, the colors are the same. I just had to move them. And on my little sheet here, this is the CPU connector that is up here where the wires originated. But this is where they end up, is where they need to be. So I had to convert it from here to here so that it matched these pin numbers. And once you do that, you have yourself a 7-digit display system, assuming that you have all the, you know, the correct, you know, master display board, and of course the 7-digit displays. In this case, they're LED, but you could have used glass.
Good pins.
Step 2 is the actual harness. So all the connectors are largely the same. The Barracora had this general illumination plug, which I had to make. I actually added another general illumination fuse and put in a new harness for just the GI, using that as basically a playfield GI fuse. And that got the general illumination on the playfield working. But the main thing is this connector. So there's two 36-pin connectors here and here, a white and a black one. And this one was this small 24-pin connector on the 6-digit game, originally in here. So what I did is I went to arcadeparts.com and I bought the connector here and the .062 female connector pins to put in here. And then I moved the pins from this connector to this one. So why did Williams go to a larger connector? And they did that because of the soundboard. Starting with System7, they added the connector right here for sounds, where they used to use a driver board. These are the rotten dog ones. These are crap compared to those. So back in the day, they used, this is a driver board, they used these connectors over here for sounds. So when they went to System7, they said, hey, we don't want to use all these tip transistors that we could be using to drive coils. We don't want to use these for sound. So what they did is they added another PIA chip to the CPU board and this connector for the soundboard. So that meant that they had, you know, another half dozen driver transistors to drive coils. Each one of these drop targets is individually resettable, and these ones too. Makes the game a lot more interesting like that, but there's a coil for that and hence a driver transistor for that.
Behave.
Had to make a special connector here to go directly to the soundboard up here, and then took the existing wires that were allocated to go up to the soundboard on the System6 system and plug them into this guy. Now you might be wondering how I figured out the allocation of the pins, because it's not as easy as you might think. I made a little chart here. This shows me the 9x4 or 36 pins that are required to move from this connector to the large connector. So I use this little map that I drew out and just put all the wires in here. And then I added 2 pins right here, 2 wires here that could go over to my display board for the commas, because they use the PIA. They actually use the sound PIA outputs to drive the commas for that board. And then also wired this guy directly up to here to get my soundboard to work.
Sound now.
So next up, this was the soundboard I had, a System7 soundboard. You can see a note I wrote down here, works but intermittent. Actually, what the problem was is that if I booted the soundboard, this is a System6 transformer with a speaker and a flipper and some other bridge rectifiers, but basically you need a center tap 12-volt transformer to power this guy up, because it makes both 12 volts and minus 12 volts for the sound amplifier. So that's why I'm using the System6 transformer. If I power up the soundboard, I could hit this switch. Turn the volume down a little bit, and you can see it seems like the soundboard works. But the trick was, if we power the soundboard back up, if I ground these inputs, this is what comes from the CPU board and what the PIA grounds to get individual sounds like that. And that's how it should work. Unfortunately, this did nothing when I grounded the pins. And if you look at the schematic, what happens is it goes through some resistors and this SIP and some caps and ends up right here on this 4050 CMOS chip right here. And usually this is your culprit when these sound inputs don't work, but it still didn't work. So then I went directly to the PIA itself, and you can see I have the 5 inputs I have up here tagged down here on the PIA, and I can actually hit the chip itself and get the sounds. So I knew that it was something between here and here that was causing the problems, but I know this chip was not bad, because I could put a logic probe on there and watch all the inputs go low when I would hit them here, and I would see it come through here. But the trick was, there is a chip right next to it here, which is a let's see, what is this thing? It's a 4068 chip, and that guy was bad, and that's what caused all my inputs to not work. So here's the schematic, and here is the inputs, and here is the IC5, the 4050 chip, and then you can see that it just goes pretty much directly to the soundboard PIA. But if you go off into the weeds a little bit, you'll find this guy right here, IC6. This was the 4068 that was bad, because it ties all these to basically, if they're not being set off, it ties them high, I believe. And this guy was bad, leaving all those things at the PIA high. So this guy was causing my problem. Now the soundboard is all sorted. I figured I'd turn the game on. So I pulled the coil fuse here. Just pull it out so there's no power to the coils, and put the game into switch test to make sure all the switches worked, which they did. So now I figured I'd put my coil fuse in like that, turn the game on, and this chip, look at that hole in the top of it. It blew the top right off that chip. So what is this chip? It's a, let's see, what is it? A 7406, and it's part of the switch matrix over here. So I was getting coil voltage somehow through the switch matrix, which are these 2 connectors. And foolishly on my part, what I should have done is pull these off and measure each one of the 8 rows and 8 columns to ground to make sure there was no coil voltage. Indeed, one of the lines did have coil voltage, so it's sending like 40 volts DC through this chip and then through, I believe this PIA right here, because it blew this guy up too. So it not only blew the top off that guy, it blew this guy up too. So the trick was, how do you find that problem? You know there's coil voltage. Well, you got to figure out which row and column it is, and then lift the playfield and start looking.
Do your job.
So this playfield hadn't been in a game for at least 20 years, and it had been knocked around and got a lot of abuse, and there was some mouse problems where they had chewed through the wiring. I had to redo all this up here because the wiring was just eaten through by vermin. But ultimately what it was is the row for these 5 switches here and these 3 were the culprits that weren't working. And what was happening, I had to remove this drop target out of the connector here and here to make that easier to get this guy out. There was one of the windings on the coils was shorting against the metal frame of the drop target, and that was getting us coil voltage from the coil through the metal frame to a switch blowing up the board. Took a while to find that. Point out we had to do a couple cabinet modifications. These side rails, I don't know how they are on Barracora, how they're supposed to be, but this had to be cut out because it was bending, or it's actually preventing this rollover from working. And over here, this had to be cut out because it was hitting, I think it was hitting the drop target, or no, I think it was hitting that guy up there. So in order to get the playfield to come down, I had to modify the side rails a little bit. One more thing I had to do in the cabinet is add a bell. So this game, I believe the Tri-Zone originally had a knocker. I didn't have the bell that Williams used. This is like a Bally 1960s slot machine bell, which actually sounds pretty much exactly like the original Barracora bell. So I had to hook that into the red wire, which is hot, and then this brown and blue is the knocker coil. And then what the bell does is, like, if you add credits, he rings. Also, if you win a game, they use the bell instead of a knocker.
Make noise.
On the back box, that return wire that goes to the driver transistor comes in here, and there was nothing on this side. So I ran and put a new pin into this connector housing and ran a wire up, and it goes to pin 5 over here, and put a new pin in there with that wire, and now my bell works. Also had to move a couple light bulbs. For instance, Game Over was down here somewhere, and I had to move it up here. The socket was already there. I just used one of these bendy LEDs to move it over so it matched the Game Over on the glass. Also had to move, this was the high score to date. So what I did is I moved it over here. I actually had to drill that hole, measured it and drilled it, and then moved the socket over. And then I converted this to general illumination like these bulbs, so it would light up the Barracora better, and also the high score to date lamp. And the tilt, this socket was already here. I just had to wire it in. Tilt was originally down there. I moved it up to here. One caveat in this was the yellow with a brown stripe wire wasn't on there, so I had to add a wire onto here and run it up to the socket. But other than that, the red wire actually was already here to do that. So just some minor movement to get all the lights set up so that they light properly on the back glass. Not much, just 3 lamps.
Time to make the donuts.
I believe we are ready to try a game in our Barracora. So let me hit the start button here. And we are playing Barracora. Now the trick to this game is, of course, you have to put the drop targets down in order. Like if I put them, watch, if I put it out of order, immediately comes up. I got to go in order. And once you do that, you light both locks for multi-ball. So it's got a little relay that pulls in that allows me to shoot the ball in there. Then I get another ball here, and I can put a ball in here, into that lock. And then it'll put the third ball here, and as soon as I score a switch, it'll basically release for 3-ball multi-ball. So now we had 3-ball multi-ball while there for a second while I play one-handed. So, you know, and we're rocking and rolling with a Barracora. So bottom line, was this worth all the trouble? It was a lot of work, I kid you not. Making this little map took a lot of time. Making new connectors for the soundboard, getting the soundboard working, fixing the switch matrix issue caused by a shorted coil. All these things took a significant amount of time. But in the end, you got a game that's fairly rare and actually a lot of fun to play. So was it worth it? Sure, why not? I mean, if you got a Barracora playfield or some other System 7, you can put it in a System 6 cabinet with a bit of rewiring and a bit of work.
Cable me this.